Hello everyone. Good evening and welcome to the session. This is week 2, session 2, right? So hope I am audible to all of you.
Yes, sir.
Yes,
Yeah.
sir.
So on Friday we kind of started with week 2, and in week 2 we all know it is system of linear equations, and I have emphasized on what key skills that you have to definitely learn in week 2. And then we kind of started off with the system of linear equations and what is the best way to represent it to solve it, which is matrix vector form. And then how to solve a system of linear equations we have seen theoretically. And then with examples, we sort of took two examples. One with the three equations, three variable system, which doesn't have a solution. And the reason being, the left hand side, we have a zero row. And on the right side of that vertical line, we have a non-zero value. Therefore, the system will not have any solution. And we have also seen another example with three equations, two variables, right? And this system actually has a unique solution, right? So these are two different types of solutions that are possible. And there is third type, which is a system can have infinitely many solutions, right? So we'll see an example of that type also. So you can see we have solved till the very end, and it has an unique solution. So only one value for x and one value for y. Right. So today we will continue this. We will see systems which has infinitely many solutions. If it has infinitely many solutions, how do I represent the solution set? Right. So that is one thing that we definitely have to learn. And then we will also see an example where the system of linear equations will not be given to us directly. Rather, it will be given as an information or data. So from there, we have to first form the system of linear equations, and then we have to solve it. All right, so we'll see them. And then I will open this platform. And if you have any doubts in week 2, you can, week 2 or week 1, you can ask me and I will address it. It can be from any of the questions except graded assignment week 2 question. Okay, so let's begin. So here is the system with three equations and three variables. Right, so this is a system of linear equations with three equations and three variables, and the variables are x, y, and z. Right, so hope my screen is visible clearly. Okay, I'll just zoom it a bit for you guys. All right, so the very first step should always be this we have discussed, right? So step 1 should always be writing the given system of linear equations in matrix vector form. So the matrix vector form of the above system of linear equation will be this, right? So the first row will be 1. Anybody? 1. Okay, so let me wait and see.
1, 2, and 3.
1, 2, and 3. The second row will be
2, 3, and 4.
2, 3, 4. Correct. So the first row will contain the coefficients of the first equation. Right. So the coefficients of the first equation are 1, 2, and 3. And second row will contain 2, 3, 4. Third row will contain 3, 4, 5. Alright, so this will be 3, 4, 5. And we'll just have this vertical line just to differentiate that these are coefficients, and after that vertical line that we are going to write is the constants that are there to the right side of the equality sign, which are 1, 3, and 5. So this is the matrix vector form of the given system of linear equations. Now, what should be our goal? Our goal should be doing some row operations such that the lower side of the diagonal entries will become 0. So we have to make this as 0, this as 0, and this as 0 in the same order. So we'll try to make this as 0 by using some row operations, by doing some row operation, and then we'll make this 0 and then this 0. Right, so this is row 1, this is row 2, this is row 3. So I have to modify row 3. Right, so I have to modify row 3 with what row operation should I do so that this will become 0? 3 should become 0.
R3 minus 3R1.
Correct. So our row 3 should be R3 minus 3 times R1. So you multiply 3 to row 1 and then do the subtraction from row 3. Then we'll get. So we are not changing the row 1. Row 1 will stay as it is. We are not changing row 2 also. It will stay as it is. And row 3 will change. Row 3 will change to row 3 minus 3 times row 1. If I do that change, this will become 0 because 3 minus 3 times 1 will become 0. Similarly, 4 minus 3 times 2, which is 6. So 4 minus 6
minus 2.
minus 2. And then we have 5 minus 3 times 3, which is 9. 5 minus 9 is minus 4. So we should not stop here. We should also do the same thing to the right side of this vertical line also. So here 5 now will get changed to 5 minus 3 times 1, which is 3. So 5 minus 3 is 2. Right. So we have made this 0. Now our next target is this entry. Instead of 2, we have to make that 0. So I can make that 0. I'll write it like this. So now I want to change this row 2 and using this row operations. So I can do row 2 minus 2 times row 1. Right, because I have 1 here, I have 2 here. So if I multiply 2 to row 1, then if I subtract, so 2 minus 2 will become 0. So now my matrix will change to 1, 2, 3, 1 because I am not changing row 1 at all. Even row 3 also won't change. 0 minus 2 minus 4, 2. So the only row that changes is row 2. So now row 2 will now, instead of 2, it will become 0. Now for the second entry, 3 minus 2 times 2, which is 4. So 3 minus 4 is minus 1.
Mimi എന്നാണ് Mimi.
Okay. So 3 minus 4 is minus 1. Similarly, the third entry will be 4 minus 3 times 2, which is 6. So 4 minus 6 is minus 2. And here, this side also 3 minus 2 times 1, which is 2. So 3 minus 2 is 1. So this will become 1. We are not done yet. So we can still make zeros, few entries zeros. So this entry we can make 0 by multiplying 2 to row 2 and then subtract. Right. So there is still some row operations left. So now row 3, I wanted to change it again. So row 3 minus 2 times row 2. If I do that, so this will be 1, 2, 3, 1, and 0 minus 1 minus 2, 1. And then this will be 0. This will be 0. And the third entry will be
0.
minus 4. Minus 2 times minus 2 is minus 4. So minus 4 minus minus 4, which will become 0. Similarly, 2 minus 1 times 2 is again 0. Right? So this is the best reduced form that we can get in this matrix. So we cannot make zeros further. Right? So this is the best we can do. And if you see the number of non-zero rows here, there is number of 0 rows. So there is 1 0 row. So this is a 0 row. And this 0 row will has all zeros actually. On the left hand side of the vertical line is 0 and the right hand side is also 0. Therefore, solution exists. So there is no case that solution does not exist. So solution exists. Now we have to check whether it is unique or not. So that's the only thing. Right? So solution exists. Now if I just see the above 2 rows, I have 2 equations and 3 variables. Right? So if I write it back to the equation form, I'll have x 1 times x plus 2 times y plus 3 times z is equals to 1, and 0 times x minus 1 times y minus 2 times z is equals to 1. And if I simplify this, I'll have x plus 2y plus 3z is equals to 1, and minus y minus 2z is equals to 1. Right, so now I have 2 equations and 3 variables to solve. Right, so if I just look at this below equation, if I just give some value for z, I will get correspondingly I will get some value for y, and if I substitute them in equation 1, I will get some value for x. If I change the value that I give for z to something else, then the value for y will change and correspondingly the value for x will change. So that means if I just keep on giving values for z, my pairs or triplet xyz values will change, and all these triplets will satisfy both the equations and also satisfy the initial equations too. So what I mean is, with these 2 equations, I can generate infinitely many solutions just by giving some value to some variable. You can take it to be z or it to be y. So you give some value to z, you just say k, where k belongs to some real number. Okay, so let z is equals to k. So the difference between z and k is, now k is a constant, z is a variable. So k is a constant which is a real number. It can be 1, 2, 1.53, anything. We have given, we let this, right? So we have given some value to z, which is fixed. Now if z is k, then from the second equation, from this equation, I'll have minus y minus 2k is equals to 1. Right? Because now that z takes value k, I just substituted that value. Now y becomes 1 minus 2k. Minus 1 minus 2k. So all I did was I took minus y to the right hand side and 1 to the left hand side. I will have y to be minus 1 minus 2k. And now I have values of z and y in terms of k. All I have to do is to substitute them in equation 1. If I do that, I'll have x plus 2 times minus 1 minus 2k, which is the value for y, plus 3 times k should be 1. Now if I simplify this, x minus 2 minus 4k plus 3k is equals to 1. And x is equals to, I'll take minus 2 to the right side, it will become 2 plus 1, which will be 3. And minus k on the left hand side, if it goes to the right side, it will just become plus k. So x will be 3 plus k. Now I have the value for x, the value for y, value for z in terms of k. K is any real value. You give 0, then z will become 0, y will become minus 1, x will become 3. So that will form a solution. So this is one solution. So if k is 0, then z will be 0, y will be minus 1, x will be 3. If you just take these values and substitute them in these equations, you will see that all three equations will satisfy. And that is one possible solution. That is not the only solution. So if you change the value for k, this z will change, y will change, and x value will also change, and that will form another solution. So since k can take any real number, and real numbers are infinite, right? Uncountably infinite. So I can have infinitely many solutions possible. If I change k, I will have different set of values. Okay, so this is just one possible solution, not the only solution. Now how to write the solution? So the solution for this system is, we will represent it like a vector. So x, y and z is the solution, and x is 3 plus k, y is minus 1 minus 1 minus 2k, and z is k. Now since this is vector, so I can write this as sum of two vectors, where one vector will have only the constants and another vector will have this k terms. And this minus 3 minus 1 0, plus I can pull this k out of this vector, k times 1 minus 2 1, and k belongs to a real number. So this is the complete solution set for this infinitely many solutions possible case. So this will be the solution. So you change the value of k, you will get different possible combinations for x, y, z that satisfies the given system of linear equations. Therefore, this system has infinitely many solutions, and these are the infinite solutions that are possible. So it's very hard to write all the infinite solutions, right? So write and show. So therefore, we will write it compactly. So we'll take some value k, and using that k, we will write x, y, z in terms of k and represent it in this way. Okay. Any doubts in this?
Yes, sir.
Yeah.
Hello, sir.
Yes, yes. Yeah, am I
Sir,
audible?
initially, all the three questions are given. Yes, sir.
Mm-hmm.
Initially, all the questions are given. So we write in the matrix form as 1, 2, 3, 2, 3, 4, and 3, 4,
Mhm.
5. And answer is 1, 3, 5, right? Sir,
Answer,
can we
not
apply
answer. Yeah.
row 2? No, sir, that is equal to जो
I got it. I got it. Yeah.
first equation equal to 1.
Mm-hmm.
Sir, can I write as R2 minus R1 and R3 as R?
Oh, sorry, Ashish. I lost you in between. Can you repeat?
Uh, Sir, in the matrix form initially,
Mm-hmm.
can I use R2 as R2 minus R1 and R3 as R3 minus R2?
Okay. So if you do that, what will you get? You will get 1, 1, 1 in the first three, in the
Yes,
first
sir.
column, right?
So second row and third row is same 1, 1, 1, 1, 1, 1.
Okay.
After applying R3
Okay.
R,
So got it. Got it. Yeah. Yeah. So the numbers are like this. So that is why it made little sense to subtract R2 minus R1 and R3 minus R2. You will get, if you do that, you will get this matrix, right? So 1, 2, 3,
yes, sir.
1, 1, 1, 1, 1, 1. And then here also you'll have 1, 2, 2,
1, 2, 2,
right?
2, 2.
Then if you just
Yes,
subtract
sir.
R2 minus R3,
Yes, sir.
you will have something like 1, 2, 3, 1, 1, 1, 0, 0, 0, 1, 2, 1. Sorry, 1, 2, 0, right? Then if you subtract R2 minus
Yes,
R1 to make this 0, so this also should be 0, right? So in order to make it 0, if you do R2 minus R1, you will get the same thing that we did. Like you'll get 1, 2, 3, 0, minus 1, minus 2, 1, 1. Yeah, you can do whichever way you want, but ultimately it should be in the reduced row echelon form. Okay. So here the numbers are continuous.
okay.
Continuous, I mean 1, 2, 3. It has some symmetry. 1, 2, 3, 2, 3, 4, 3, 4, 5. So that is why when you did this R2 minus R1 and row 3 minus row 2, you got 1, 1, 1, 1, 1, 1. But if the values are different, then it will be different. You will not get that symmetriness. Right. So our ultimate target should be making the lower side of the matrix to 0. That's our ultimate goal. All right.
Sir, can't we say by looking at the row 3 that all the elements are zero? So can't we say directly that it will have infinitely many solutions?
Yeah, it will have infinitely many solutions, but the question is solve the given system of linear equations, right? So you should also give the system solution.
Okay, but we can say directly, no?
Yeah, it's
Uh,
an infinite. Yeah, you can say if the question is about what type of solution this particular system has, then you can stop till infinitely many solutions. But if the question is asking for the solution, then you have to solve till the very end.
okay, sir.
Okay. Yeah. So since the question is about solve the QN system of linear equations, we have solved it at till the end. So we have given the solution. Had it been like previous type, had it been like this, the system has, then from here itself we can conclude that the system will have infinitely many solutions. All right.
Okay. So we would not have any case in which we are getting like a unique solution or something, even if the row is zero.
No, we have seen that. No, this is that case.
No, it was a two variable, no?
Sorry.
It was a two variable question.
This was a two variable question, but see, when we'll have unique solutions when the number of variables and the number of non-zero rows are same. Okay, so here I didn't mention that, but our number of non-zero rows R is 2 and the number of variables n is 3. So R less than n. Therefore, this will fall into the infinitely many solution case only. It will not have unique solution at all. Right. So only when your R is equals to n, you will have unique solution.
Okay, sir.
Okay. All right. So it could be slightly confusing which variable to be taken as constant, right? So sometimes this question might arise: why should only z be given taken k? Why not y or why not x, right? So there is some small theory behind this, and I think professor has not mentioned, but you can use this as some small trick. Okay. So there is a thing called pivot element. Do anyone know about this? Pivot. Those who know, can you raise your hands, please, so that I'll get to know. Okay, all right. So this is not very difficult. So I'll take this only and try to give you small gist on what this pivot element is and how this is useful for us to consider the variables. Okay, so if you have any matrix, something like this. Okay, so pivot element is the first non-zero element in every row. Okay, so what is the pivot element? It is the first non-zero entry in each row. Okay, are called pivot elements. So here, if you just walk through the rows, you can find the pivot elements. So in the first row, the first non-zero entry is 1. So this is the first non-zero entry, right? So that's it. Each row will have only one pivot element because we are only interested in the first non-zero entry in each row. And if you just go to the second row and try to identify the pivot element, you will see that the first entry is 0. Therefore, it is not the pivot element. The second entry is a non-zero entry. Therefore, that is a pivot element. So once you got a pivot element in the row, you don't have to go through all other entries, right? So you can go to row 3. Unfortunately, row 3 will not have any pivot element because all the entries in this particular row are zeros. So therefore, this matrix has 2 pivot elements, but it's a 3 cross 3 matrix, right? So again, since this is the matrix vector form of the system of linear equations, each column corresponds to a variable, right? So the very first column corresponds to the coefficients of x. The second column corresponds to the coefficients of y. Third corresponds to the coefficients of z. So you can scroll up and see. When you write the matrix vector form, you can see that this column entries 1, 2, 3 are these 1, 2, 3s. Right. So this column entries 2, 3, 4 are 2, 3, 4, which are coefficients of y. 3, 4, 5 are the coefficients of z, and that 3, 4, 5 are in this column. Right. So you can see that column x has a pivot element, column Y has a pivot element, but column Z does not have a pivot element. Therefore, you can take column Z as a free variable and give any value to Z, and then find Y and X in terms of Z. Okay, so that is what I did here. I have taken Z to be some constant because Z is a free variable in this case. Okay. So you can use this and write the solution for infinitely many cases easily. Okay, hope this is clear. We can move to the next thing.
Sir, can you repeat this?
This one, is it? This pivot thing completely. Or any specific place?
Yes.
Okay. So for choosing which variable to be taken as k constant, you can use this idea. Okay, so identify pivot elements in each row. What are pivot elements? Pivot elements are the first non-zero entries of each row. Okay, and that too, you just have to identify these pivot elements only after you write the reduced row echelon form, not the initial matrix. So you try to make some entries 0, and that too from the bottom. You make entries 0 and make zeros as much as possible. That's row echelon form, right? So after you write the row echelon form, then you identify the pivot elements. Pivot elements are the first non-zero entries of each row. So first entry itself is non-zero, therefore that is a pivot element. In the second row, first entry is 0, so it cannot be pivot element. The second entry is -1, therefore that is the first non-zero entry of second row. Therefore -1 is also a pivot element. When I go to the third row, first entry, second entry, third entry, all three of them are zeros. So none of them can be pivot element. So once you identify these pivot elements, then you look at those columns which has pivot elements, or you look at those columns which does not have pivot elements. Okay, only the column Z does not have the pivot element. Rest X and Y has pivot element. Since Z does not have the pivot element, you choose our variable Z to be a free variable. Free variable means it can take any value on its own choice. Okay, so that is why I took Z as some constant k. K can be any real number. It can take any free value. Once Z can take a free value, Y and X are dependent on Z. So if Z is k, Y is -1 -2k, right? And X is 3 plus k. And this gives us the complete solution. Is this clear now?
Yes, sir.
Okay. Okay, great. Then let's move to the next important skill that we should develop, which is given from the information, how do I form a system of linear equations? Right. So from the information, how do I form the system of linear equations? Right. So this is a web network with 4 pages, and I think this is also explained in the lectures also. Please do watch it. And when you search something in Google, right, it gives multiple pages, but it gives in order, right? It gives the first link on the top, first or the best link on the top, and then followed by the second, followed by the third, and so on and so forth, right? And this ranking is not random, right? So it is not random. Whenever you search for something, for example, if you search for IIT BS, right? Even you search today or tomorrow or any time later this week, the first thing that pops up is our website, right? So IITMBS website, right? Because it has the most information. So it's not random. Rather, Google actually uses this algorithm called PageRank algorithm. So it actually assigns some importance to each of the pages, web pages, and it orders which has the highest information in it. Orders in such a way that which has the highest information pops on the top, then the second one, then the third one, and then the fourth one. So how does this PageRank algorithm work is it will give some importance score to each page. And here in this example, that importance, since we don't know the importance, A, B, C, D, these are the 4 web pages. Since we don't know, we just denote it by variables. So XA, XB, XC, XD are the importance of each page. Importance score or whatever you call is given for each page. Right, so this is XA. This page has XA information, XA importance. And this is XB. And this is XD. And this is XC. Now, what does this edges represent? The PageRank algorithm is used to assign importance scores to each page based on the links between them. Right. So, what are these links suggest is if I open page A contains some information about page B and page C. So that means some importance of C and B are being shown in A. And that's the only information A has. In B also, you see B has information about A as well as D. And some information of B or the importance of B is shown in A as well as C. So those are these arrows, these one directional arrows represent. So this direction represents that C has some importance of B in this page. Okay. So the overall importance of A is XA, and that overall XA is shared by 2 pages, one by B and one by C. So overall importance is XA and it is being shared by 2 of them. Therefore, the importance is equally shared to both of them. So XA by 2 and XA by 2. Similarly, B has XB importance, and that importance is being shared to A and D. Right? So yeah. So this is XB by 2 and this is XB by 2. Similarly, for C also, it is XC. C web page C has XC importance and that importance is being shared to 2 of them. So XC by 2, XC by 2. And D has only one link. Right. So all the information that D has, importance that D has is about C. So this is XD. So now if you see XA by 2 and XD combined will give us the importance of C. Or we'll start from A. So A has XA importance and that importance you see the inward coming edges. That importance is basically from one web page, which is also giving only importance of xb by 2 importance. So that means xa has only one importance, and that importance value is xb by 2. So xa is basically xb by 2. And then xb, if you see, xb you have information or importance coming from A, importance coming from C. So therefore, the total importance of xb is basically, just a second. Uh, yeah. So xb is xa by 2 plus xc by 2, because the importance of B is from web page link A and web page link C, and not the total importance of A and C. It's half importance of A and half importance of C that is coming. Uh, you should all excuse me. Just give me a minute. I apologize for this. I have to take this call. Yeah. Hello. Sorry for that. Okay. So let's continue. So the total importance of each page comes from the other pages, right? So XA importance is coming from page B and page B alone, and that page B has information shared to A as well as D. So therefore, the total importance will not be given to A. It's only half of the information. So that is why we had XB by 2 equals to XA. Similarly, XB also, you can see XB's importance is in A as well as C. And in A also half information, half importance, and C also gives only half importance. So XA by 2 plus XC by 2 will give the total importance of B. Similarly for C, you see the total inward coming edges are 2. So the total importance of D is given to C, as well as half importance of A is given to C. So therefore XC will have XD plus XA by 2. And XD will have importance coming from C as well as B, but not the total importance, only the half importance. So from the given graph. So we call it graph actually. It's graph of directed graph with some edges and vertices. So from the graph, we kind of form a system of linear equations in terms of four variables, which are xa, xb, xc, and xt, which are nothing but the importance scores of each pages A, B, C, D. And yeah, so we have four equations and four variables case. So these are four equations and four variables. Right, so you can further simplify this. We can further simplify this. So you can write this whole system as you multiply 2 to xa and take xb also to the left side. So you'll have 2xa minus xb is equals to 0 is our first equation. And then xa minus 2 times xb plus xc is equals to 0. And then xa minus 2xc plus 2xd is equals to 0. And then xb plus xc minus x 2xd is equals to 0. So this is the simplified form of system of linear equation that actually describes the importance of xa, xb, xc and xt. Right, so once you form this system of linear equations, the second thing is you should also find which page is important, right? So that's the ultimate challenge or ultimate goal. So for finding xa, xb, xc, xd, we have to solve this system of linear equations. Right, so for that, we have to write the given system in matrix vector form. So this will be 2 minus 1. So equation 1 has only two variables in it. We don't have xc and xd, but we can add xc and xd by adding 0 times xc plus 0 times xd. Right, so 0 and 0 will be the coefficients for xc and xd. So if you don't have any variable in any of the equations, you just add that variable by multiplying a 0 as its coefficients and then add it. So 0 times any variable is 0, so it will not change the equation at all. So 2 minus 1, 0, 0, and we have 0. Similarly, 1 minus 2, xc coefficient is 1 and 0. xa coefficient is 1 and there is no xb, but as I said, you can add plus 0 times xb. So this will give 0, minus 2, 2. And the last equation does not have a. Therefore 0, 1, 1, minus 2. And these are zeros. So always be careful while you write this. So just make sure that each column you have written is correct or wrong. So this column should correspond to xc's coefficients in each of the equation. This column correspond to xb's coefficients in each column. Similarly, xc and xd. You just cross verify and see that it is consistent. So once you form the once you write it in matrix vector form, now our challenge is to make these all entries to 0. Right? So anyway, this is 0, but this is 0. We should also make this 0. Right? So we'll do that. What we can do is we can take half of the first row, right? And then subtract row 3 and row 2. So you can do it simultaneously. There is no harm of doing it. So row 2 I will change to row 2 minus half of row 1. Parallelly, I will change row 3 to row 3 minus half of row 1. Right, so if I do that, I'll have 2 minus 1, 0, 0. This is 0. And the last row is also 0, 1, 1 minus 2, 0. And this row will become 0. And minus 2 minus of minus half. Right, so minus 2 plus half, it will just become minus 3 by 2. Minus 3 by 2 is minus 1.5. And then this will stay as it is because 0, 0. So 1, 0, 0. Now this will also become 0. Now 0 minus of minus half, which is 0 plus half, it will just be half, which is 0.5. And minus 2, 2, 0. Right, so we made these zeros. Now we have to make these zeros and then this 0. So in order to make this 0, we can just simply multiply 2 to this and then subtract. Right, so row 4, I'm going to change it as row 4 minus 2 times row 3. If I do that, I'll have 2 minus 1, 0, 0, 0, 0 minus 1.5, 1, 0, 0, 0.5 minus 2, 2, 0, and then 0. So this row is changing. So 0, 0, and then 1 minus 2 times 2. Right, so 1 minus 2 times 2. 1 minus 2 times minus 2, it is 1 plus 4, which gives us 5. Similarly, minus 2 minus 2 times 2. So minus 2 minus 4, it will give us minus 6. And this is 0. Right now, what we'll do? So we'll just do we have to make this 0. This 0. So for that, we'll do row 3 have to be changed from row 3 plus 1 by 3 row 2. Right, so if I just do 1/3 of row 2 and then add, I'll have this entry to be 0. Now this will become 0, this will become 0. This will become minus 2 plus 1 by 3. It is minus 6 plus 1 by 3. So minus 5 by 3. This is minus 5 by 3. And this is 2. And this will be 0. And the last row, we are not changing it. 5 minus 6, 0. So now what we can do is we can multiply 3 to the row 3. So if you multiply 3 to row 3, or minus 3 to row 3, we'll have row 3 and row 2, row 3 and row 4 to be the same. Zero 5 minus 6 0 0 0 5 minus 6 0. And now if I just simply subtract row 4 with row 3, I'll have 2 minus 1 0 0 0 0 minus 1.5 1 0 0 0 0 5 minus 6 0 0 0 0 0 0. So the last row became 0, and the system is also consistent. That means it has a solution because this is also 0. Right. So the number of non-zeros R is 3. There are 3 non-zeros, but the variables are 4. Therefore, the system has infinitely many solutions. Right. So system has infinitely many solutions. But since we are interested in computing the values of XA, XB, XC, and XD, which corresponds to the scores, importance of scores, right? So which are sort of positive values, right? So that's what we usually take, right? So we will not take like something like -5 importance. It doesn't make sense, right? So importance is a positive value that we give to each variable. So, and also we have to find which page is important. So you don't have to worry about what value of XA, XB, XC, XD. We just need comparison. We just have to order them. Is XA greater or XB greater or XC greater or XD greater? So that's the only thing we want, right? So for that, if we find the solution, we might get some interesting conclusions. But before that, as I said, let's identify the pivot elements. So 2 is a pivot element, minus 1.5 is a pivot element. For row 3, 5 is a pivot element. So this is XA, XB, XC, and this is XD. So XD column doesn't have any pivot element. So you can choose or let XD to be some K, where K is not a real number now. K is some positive real number, right? So, or in our, if we have to understand this easy, K greater than 0, right? So I have given some importance to K, some importance to XD. Why only XD? Again, the reason is being XD is the free variable to choose. So I have chosen XD to be K. So once XD is K, you see this row, if I write it in equations, I'll have 5XC minus 6XD is equals to 0. Right? So this is equation 3. From this equation, I'll have 5XC to be 6K because XD is K. So from here, XC is 6K by 5. Right? So XD is K. Then XC is 6K by 5. Now XD and XC I have. If I just scroll up and take equation 2, equation 2 is minus 1.5 XB plus XC plus 0 times xd is equals to 0. So therefore 1.5 xb is equals to xc. xc is 6k by 5. So this is 1.5 is 3 by 2. 6k by 5. So this and this will get cancelled out. This will give me xb is equals to 4k by 5. Right. So xb is 4k by 5. So now I have xt, xc and xb. From equation 1, I can get xa also. So equation 1 will be 2 times xa minus xb is equals to 0. From here 2 times xa is xb. So 2 times xa is xb is 4k by 5. From here xa will be 2k by 5. Right. So therefore, the solution for the given system of linear equations is xa, xb, xc, xd is xa is 2k by 5, xb is 4k by 5, xc is 6k by 5, and xd is k. So if I pull out k, I'll have 2 by 5, 4 by 5, 6 by 5, and 1. And k is greater than 0. So once k is greater than 0, you can clearly see that this 2 by 5, 4 by 5, 6 by 5, and 1 are just the values that are getting multiplied to k. And among these 4, 6 by 5 has the highest value compared to other 3. So therefore, you take any value for k, the importance for c will be greater than other pages. I can easily rank them irrespective of value k. So xc will always be greater than xd, will always be greater than xb, will always be greater than xa. So a has the least importance, c has the highest importance. So therefore c page pops up first, then d in the second, b third, and finally a. Okay. All right. So this is one good example where system of linear equations comes into the picture, and you have to solve the system of linear equations to rank the pages. Any doubts? From anyone? All right.
No, sir.
So good. So these are some examples where I showed different types of solutions, and if at all solution exists, how to find the solution. And those are the key skills that you also have to develop, solve different types of problems, right? And get a good hands-on experience on this concept. And yeah, so that's about the week 2. If you have any doubts, you can ask me from any of the activities or practice assignment which are difficult to you, or if it is okay, if all of us are happy, then we can save our next 1 hour and we can use it on something that is much more productive. Any doubts from anyone? Yes. Somebody raised, right? Amit. Yeah, Amit, I can't hear you actually. Can anyone hear Amit?
No, sir.
I hope you unmuted, but we can't hear you, Amit. Can you rejoin and check? Yeah. Maybe you can post your question in the chat also. Try rejoining. If it doesn't work, then post your question here. Okay. Meanwhile, if others doesn't have anything to discuss with respect to mathematics, you can discuss something else also if you're interested. Okay. Then all right then.
Sir, one question. The
Yes.
the assignment actually I missed this invites last week. I was not very sure how to get into it, but I got some support from the support team, and this is my first session actually. So the assignment, it was mentioned that you have to upload the handwritten assignments and all that. So it is the same assignment what we fill in online, which has to be handwritten and uploaded, right? That's my understanding.
Correct. Yeah.
Okay. So
So you see.
Actually, I actually did
Sorry?
it online. I did it online last week, but I did not upload the assignment physically. I mean, handwritten, because I was not sure about it, what is to be uploaded. But with the help of the support team, I was able to figure out today. So
Okay. Okay. See, with respect to that, I would like to add few things. See, when you solve the assignment, no, even if it is on the rough paper, right? You can upload that.
Okay.
It just have to be clear that which question is written where. That's it.
Okay.
So you don't have to spend too much time on it to write it very neatly, and somebody will score you based only on that. It's not how that happens, right? So your online score matters. Parallelly, what we want is when you solving the online thing, you would have solved it at one place,
Correct.
right? Somewhere,
Yes,
right?
we are writing
Just
scribbling
upload that, just to make sure that you didn't copy or anything.
Okay.
Rather, you have solved it on your own and you have submitted the assignment.
Okay.
So that's the only thing that we want.
Sure.
That's the only reason behind asking you to submit the handwritten solution.
Got it. Because I last week, it was the first week, right? Week 1. So I was going through, with the time constraints and all of that, I was going through all these classes actually, and I was doing all the practice assignment and then the graded assignment. But when I looked into the last one in maths and I think English also, it had that handwritten assignment to be uploaded, but then it was not written anywhere that what is to be uploaded or what is the handwritten assignment. But then I figured out only today that it is the same thing what we are doing needs to be uploaded in that particular section. So I got it. I missed it last week, so I don't know whether is there any solution to it. Should I do it again or should I not do it now? I don't know, because the time is gone.
Yeah. So now that the time is done, so are you a foundation student or a qualifier student?
Qualifier.
Qualifier, okay. I think they will leverage few things for you, I guess. At least the first week, I think you might get some chance to re-upload it. I'm not very sure. Okay, so I'm not.
How do I get it? Because when I write, I mean, is there any number whom we can speak to or something like that on these kind?
Not
Because there was
really.
no
You just have to
orientation
write to
session.
support team. Support. Yes, at the rate.
Okay. Because there was no orientation in terms of what needs to be done and how it needs to be done and all of that. It was only like as soon as we got the access, it was already week 1 was released, and then we had only 8 days to do. And I was trying to figure out how to do, what to access, and where are the classes and all of that. So it was completely a chaos last whole week. So I'm falling into the track now. So Anyway,
Got it. And fair enough that since we are very new to the system and it takes some time to get adjusted to it. I completely agree what you have said,
Hmm.
and I'm not the person who can take actions on this. Okay, so
okay.
maybe you just have to mail them asking,
Hmm.
sharing your concern, genuine concern,
Okay.
and let's see what they, how they respond.
Okay. Sure, sir. Thank you.
Thanks. Yes, Amit.
Sir, am I audible now?
Yeah. Now you are audible.
Okay. Sir, I had one question, but it's related to the graded assignment. I just want to understand what has been asked in the question. So, in
All right. I will not give you the complete, maybe not even 10-20%. I will just, if it is only the explanation part, I will just do it.
okay, the very first question which is there for the
All right.
graded assignment week
All right.
2.
Yeah. So, what do you want to understand in that?
Like when it says consider the equation of a straight line ax plus by plus c is equal to 0. Now it's asking which of the statements given are correct. Now for a straight line, whichever point is on that particular line, that is a solution to that particular equation, right? Now here, does it are they asking for a system of equations in this particular format, or are they just speaking about a single line?
No, it's not. It's not a line actually. You just have to consider a straight line with two variables. That's the
Okay.
sense of it. So x
Okay.
and y are variables in that, and
Okay.
a, b, c are constants.
Okay. So then we have a general system of equations, and then related to the system of equations, this question has been asked. Because
Yes.
it talks about the consistency, which we have covered in the lectures and all. So,
Lecture. So here I will give you just the hint. So this is just an one equation, two variable case.
okay.
Okay. So
Okay.
only ax plus by plus c is equals to 0 is one equation given to you. And with
Okay.
that equation itself, you have two variables x and y.
Right. Okay.
So it's a one equation, two variable case, and you just have to comment on its consistency. Whether the system is consistent or not. If not consistent, that means no solution.
Okay. Understood, sir. Okay.
Yeah.
Okay.
So that's the lesson.
Okay. Thank you, sir.
All right. Okay. All right, guys. Then Tuesday is the solve with us session. So TA will come up with some 10 problems which are related to week 2. So please do try to attend that session, and with that we'll close week 2. So we'll move to week 3. So week 3 is, I think, it's very interesting. We'll move to the real math, which is calculus, and we'll try to make it as fun and interesting as possible. Okay, so we'll enter into the mathematical world, and we'll make sure that your stay in this world is pleasant. Okay, so all right, guys. Thanks all for joining, and we'll meet in the next session. Bye.
Thank you.
Thank you, sir. Bye.
Yes. Bye.
Thank you, sir.